Okay, so now we're going to try and use L'Hopital's rule to solve this problem right here. Well, here's our issue with this, is we already can see it is not a fraction, which means it's not going to meet that 0 over 0 or infinity over infinity criteria to be able to use L'Hopital's rule. However, I do know that when I subtract natural logs, that it does form a fraction. So if I use my rules of logarithms, this would end up being ln of x over sine x. And I would still have my limit as x goes to 0 from the right. So now if I plug in my 0, and with my logarithms, I also know that this would be the same as if I just do ln and then do the limit of the inside here. So as x goes to the right of x over sine x. So now I'm going to plug in my zeros to this. So I'm going to have 0 over sine 0, which is still 0 over 0. So I would do L'Hopital's rule with this. So the derivative of the top would be 1, and the derivative of the bottom would be cosine of x. And then I'm going to rewrite all the rest of this. So the limit as x goes to 0 from the right, and then the ln of all that. So now let's plug in my 0. So I'd have 1 over cosine of 0. Well, cosine of 0 is 1. So I've got 1 over 1, which is 1. Now that's not our final answer this time, because if you recall, we still have an ln over here. So actually what I would do is say, okay, it'd be ln, and everything that was on the inside has turned into 1. So then I would determine ln of 1 is actually 0. So my answer is 0.